Alright guys, in this video we're going to take a look at counterexamples. Alright, so this is a pretty easy topic, but sometimes it can be just a little bit tricky. So let's first start by defining counterexample. Counterexample is a fact that proves a conditional statement false. So up until this point we've talked about if-then statements. If it's raining, then I'll get an umbrella. Alright? What a counterexample does is it takes that if-then statement and it proves that it can't be true. Now, a counterexample proves something false by doing two things. First, it must make the hypothesis true. It must confirm the hypothesis. Now remember, the word hypothesis in this case is talking about the first part of my statement. That would be like the P part of my statement. If I had P implies Q, if we put it in symbolic, this would be my P statement, right? And my conclusion is my Q statement. So the first part has to be true. The second part needs to be false for this to be a good counterexample. So let's take a look at an example, then we'll take a look at the IXL that we have. So which of these is a counterexample for my conditional statement? Well, let's start with our conditional statement and see what it says. If the food is red, then it must be a tomato. So if I have some food and it's red, then it must be a tomato. Now let's go through our examples. Remember, we want the hypothesis to be true, the conclusion to be false. I need both of those things. And we'll see why counterexamples work here. So let's look at this first one, a red hat. All right, it is red, but is it a red food? Is it a red food? No. So my hypothesis is not true, so I don't even have to think about it. Because we're not talking about hats, right? We're talking about food. So if the hypothesis isn't true, that's like bringing up something from all the way over here. It's like comparing LeBron James to a football player. We're not talking about the same thing. We have to make sure we're talking about the same thing. That's why the hypothesis has to be true. All right, let's look at this next one, a green tomato. Okay, well, the first part, again, it is a food, but it's not red. We're not talking about the same thing. So that's no good either. All right, so if I look at C and D, both of these confirm my hypothesis. A strawberry, that's a red food, and a red tomato. That's also a red food, right? Now, we want the first part to be true, so that each of these gets one check. We got the hypothesis true. Now, to prove that it's false, this second part has to be not true. So if the food is red, then it must be a tomato. Well, a red tomato is a, tomato. But a strawberry is not a tomato. It proves the statement is false. It's a red food that's not a tomato. A red tomato just goes along with what we're saying. We're trying to prove this false. So first part's true, second part is false. So let's take a look at the IXL here, and let's see what they have for us. So, all right, so which of the following is a counterexample for this conditional statement? Let's make this a little bigger so we can actually read it. If an animal walks on two legs, then it's a human. So first part needs to be true. Does a dolphin walk on two legs? No. Does a frog walk on two legs? No. Does a flamingo walk on two legs? Yes, it's the pink birds with the two legs, right? So that checks out. And a human walks on two legs. So it's one of these two. Then it's a human, so we need something that's false, so that's going to be a flamingo. All right, so let's take a look at another example. If a person speaks English, then he or she is American. So we need the first part. We need an English speaker. All right, Maria is a Spanish speaker. That's no good. He's a French speaker. I'm not even going to try to pronounce that name. Eva speaks German. And then Anna speaks English. Well, this actually is really easy. She's the only one that proves the first statement true. Okay, and then we need the second part to be false. South African versus American. That checks out. All right, let's look at one or two more. If it flies, then it's a bird. So check the first part. Does it fly? A dove, that flies. A red robin, that flies. A bat flies. A penguin does not fly. Okay, so we've got it between three. then it's a bird. Well, a dove is a kind of bird, a red robin is a kind of bird, but a bat is not a bird. So that would be my correct answer. Now, this is the last example here. Notice we can also do this with math. So if you need to, some of these terms I know are maybe a little bit, there are things we had in Algebra 1, but maybe we've forgotten them, and that's okay. If a number is a fraction, so we're looking for fractions, so it could be this one, or that one of those three, not -4, then it can be written as a terminating decimal. Now, a terminating decimal means that it has an end. And if you weren't sure what this means, I would just take this and then copy it and send it into, you can actually just right click it and say search for a terminating decimal, and Google will remind you what a terminating decimal is. Well, if I plug these in my calculator, I get 0.25, 0.75, and this is 0.3 repeating. This one is not a terminating decimal, so that'd be my right answer. So that's your work for today. All right, so if you need to Google some of the stuff, some of them is going to be a little bit of facts or things that you need to know to do the problems right. But the big idea here is counterexamples prove conditional statement is false. And they do so by making the hypothesis true and the conclusion false.